Welcome to The Explainer. Today, we're going to dive into some of the hidden genius of 5G. And it's not about the raw speed you see in the ads. Nope, it's about a really fundamental redesign in how the network communicates, a huge shift from constantly shouting to intelligently whispering.
So that brings us to the big question. How did 5G learn to stop shouting? Well, to really get what makes 5G's new radio so special, we've got to first look at this giant inefficiency that was just baked right into 4G LTE. And it all comes down to how the network talks to your device.
So, before we can appreciate how clever 5G really is, we have to understand the problem it was designed to solve. And that problem is all about how 4G LTE handled its control signals, that constant stream of instructions getting blasted from the cell tower to your phone.
Okay, I want you to imagine a massive sports stadium. In the 4G LTE world, the network was basically using a PA system that was always on, full blast, broadcasting instructions across every single seat over the entire field. And it did this whether there was just one person sitting in the stands or 100,000. That's the key thing to remember. Always on, full power, maximum coverage.
Yeah, as you can probably guess, this whole method was just unbelievably wasteful. On these wide channels, it would just eat up a huge chunk of network resources just for control signals, even if there were hardly any users connected. It was totally inflexible, and for your phone, it was a battery drainer because your device had to constantly listen to this full bandwidth broadcast. It was so rigid, it even needed a completely separate channel just to yell out how big the shouting area was going to be.
Okay, so how on earth did 5G fix this incredibly inefficient system? Well, it basically threw out the old playbook and came up with a brand new concept, something that's absolutely central to how it works. It's called the core set.
So instead of that giant stadium-wide PA system, think of 5G using a targeted megaphone. A core set is just a small, specific block of network resources, and it's defined in both time and frequency, where a device is told, hey, listen right here for your instructions. The network can create these little megaphone spots anywhere, make them any size it needs to, and point them only at the devices that need them.
And this slide, man, it just lays out the difference so clearly. It's a complete change in philosophy. LTE's control channels were stuck in a fixed spot, always at the very beginning of a transmission and always using the full bandwidth. 5G is the total opposite. Its control channels can be put anywhere, they can be whatever size is needed, and because of that, they're incredibly efficient and scalable.
All right, so let's get a little more specific. How does this CORS set idea totally change the game for the downlink control channel, the PDCCH? That's the channel the network uses to send all its grants and instructions down to your phone.
So how does this actually work in practice? Well, the network uses this thing called RRC signaling, which is basically just a set of direct, personalized instructions to tell your device, hey, here is your personal core set. This is the exact spot at this exact time where you need to listen. So your phone is then configured to monitor only that tiny assigned window, and it gets to ignore everything else.
And the benefits here, they're not just theoretical, they're huge in the real world. Because your device doesn't have to listen all the time, it saves a massive amount of battery life. All that network space that used to be wasted on shouting, it's now freed up for actual data. And the system is way more robust too. It supports higher aggregation levels, which is just a fancy way of saying it can send control signals more reliably, even to phones that have a really poor signal.
And this really gets to the heart of it. Unlike LTE, where a device had to be listening pretty much constantly, 5G lets the network say, hey, you only need to check in with me every 5 slots, or every 10, or whatever. For something like an IoT sensor that just sends a tiny bit of data once an hour, this is an absolute game changer for its battery life. Now, this whole idea, this philosophy of being flexible and smart, it doesn't just stop with the downlink. It totally applies to the other side of the conversation, the uplink. This is where your device talks back to the network, sending things like acknowledgments and quality reports on the physical uplink control channel, or PUCCH.
And 5G's philosophy of flexibility just keeps on going. It understands that not all uplink messages are the same. You wouldn't use a sledgehammer to hang a picture frame, right? So 5G created this versatile toolkit with 5 different formats, and it split them into 2 main categories, short and long.
Let's break that down. Think of the short formats like you're sending a super quick got it message, an ACK/NAC. They are just 1 or 2 symbols long, so they're incredibly efficient. The long formats, on the other hand, are more like a detailed status report. They can be up to 14 symbols long, and they even pack in their own guideposts, these things called DMRs, just to make sure the network can decode the message loud and clear.
And this table really shows you just how specialized this system is. Look, for those tiny little messages, maybe just a yes or a no, the network uses format 0 or 1. Simple. But when your phone has a lot more to say, like a detailed report on channel quality, it switches over to formats 2 or 3, which can use more resources. There's even a format 4 that's designed specifically to handle multiple users on the exact same resource. It's just an incredibly adaptive system, built to use the right tool for every single job.
Okay, so let's bring this all home. All these acronyms we've been throwing around, Core SED, PDCH, POOC, they aren't just a bunch of technical jargon. They're the actual building blocks of a fundamentally more intelligent network. And that intelligence is what makes everything we hear about 5G possible.
And you can see the results in real numbers. For instance, in 5G, your device can actually send 2 separate uplink control messages in just one slot. That's double what LTE could handle. And when you combine that with features like frequency hopping for better reliability, it all translates directly into a faster, more responsive, and much more robust connection for you.
And this, right here, is the real magic. This is the payoff. Because 5G learned to stop shouting and start whispering, it can build a network that efficiently serves wildly different needs all at the same time. It can give a huge slice of the network to a virtual reality headset that needs crazy low latency, while at the same time give a tiny power-sipping resource to a smart water meter that only reports in once a day.
This granular, dynamic control is the secret sauce that makes all the future promises of 5G a reality. It's an architecture that was built for a future we haven't even fully imagined yet. And that leaves us with one last thought. Now that we have this incredibly flexible and intelligent toolkit, what new innovations will it enable? Thanks for tuning in to The Explainer.